Hey everyone, and welcome to this video on Math Made Simple. In this video I'm going to be covering how to do exponents, both positive and negative exponents. So I'll also be going over just a little intro into scientific notation, a video on that coming out soon, so let's begin. Alright, so first, what is an exponent? So this is an example of an exponent. The exponent is right here. That is the exponent. And this is called the base. And when you're doing a problem involving exponents such as 3 squared or 3 to the power of 2, 3 to the 2, you will raise the base, the 3, to the exponent. In this case, it's 3 to the power of 2. So let's rewrite that. 3 to the 2. So basically here you multiply 3 by itself twice. So 3, or that would be 3 squared. So 3 squared is 9. Another way to do this would be, I should say, another problem you could do is 3 to the power of 3. This would also be called 3 cubed. So, as in, squared is raising the number to the power of 2, and squared is 2 dimensions. This is just another way to remember this. And when you're cubing it, a cube has 3 dimensions, and that's just how you can remember the exponent. When you go to the power of 4, to the power of 5, to the power of 1, to the power of negative 1, to the power of negative 2, that's all you just say to the power of negative 2, or to the power of 99. That would be a pretty big number. So, now 3 cubed, you raise the base to the exponent. 3 cubed is 27. That's a pretty big number. So as you can see, just a small number raised to a small power, say 4 to the 4, that is already a pretty big number. So now let's do some practice for positive exponents before moving on to negative exponents. So here are just a few practice problems you can do. Answers in the description. So you can pause your video to do these or come back after you finish the video. So here they are. Alright, now let's move on to negative exponents. Negative exponents are a lot like positive exponents. And I also have to show you a pattern that they make. When you're doing positive and negative exponents, let's just use 3 as our example here. 3 to cube and 3 to the power of negative 3. They both have a pattern to each other, and I will show you in a second. Alright, so here I have some stuff I wrote out. As you can see, I have 3 as my example here. 3 to negative 1, negative 2, negative 3, and 3 to the positive 1, positive 2, and positive 3. So you can see the little pattern I showed you, 3, 9, 27. And here, the pattern continues. 1/3, 1/9, and 1/27. I can see if I can get a closer view. Yeah, that's 27s. So, as you can see, there's a pattern, and it can be used with any number. And I will show you how to solve a negative exponent now, but just study the chart a little bit. So if you saw there, the pattern was the positive exponents and the negative exponents are actually pretty closely related. So let's just do solving some negative exponents now. Sorry. So make it nice and bright. My math teacher loves smiley faces. That's for you. So when you see a negative exponent, like 3 to the negative 2, we can instead of having to go like, oh my gosh, how do I solve a negative exponent like that? Because you multiply 3 by itself negative 2 times. What? It's actually equal to 1 over or divided by 3 to the positive 2. So that's also equal, and then you could divide 1 by 3 to the 3 squared, aka 1 divided by 9, yes, or 0.1 repeating. And that's what 3 to the power of negative 2 is, 0.111111111 repeating. So let's just take a look at another example. 3 to the power of negative 3. So you could also write this out as, shout your answer at your computer screen if you want. So this could also be written as, I hope you got that answer. So, and then you could solve that as 1 over 27. If you remember, 3 cubed is also equal to 27, so. And then you can solve it, and that's 0.0370 repeating. There's some confusing numbers in exponents. So, anyway, now when you use a power of 10, when you're using a power of 10, it's about powers of 10 are really important in scientific notation, and here's just a brief introduction into scientific notation. And I am making a video on scientific notation really soon, so definitely be sure to subscribe and come back, and I promise it'll be out soon, if it isn't out already. So scientific notation. So you have 10. 10, really important. So in scientific notation, the formula is A times 10 to the power of n, where A is a whole one-digit number between 1 and 10. Since 10 isn't a one-digit number, we should say between 1 and 9.9999999 repeating. And n equals an integer, just any integer in the world. Negative 23, 8, 99, n is an integer. So you can use scientific notation when you have a problem like this. Yeah, it's a pretty big number. So as you see, scientific notation can really help us with that kind of stuff. So here's just how you use it. So you have 2100000. I'm not going to write out the full number because it's huge. So let's say your decimal point here and you add a 0.0 at the end. So this is a fairly large number, right? Yes, it is. It's large. So what we want to do here is we want to find a whole one-digit number between 1 and 10. So 2 is a whole one-digit number between 1 and 10. So we'll take our decimal point, 1, 2, 3, 4, 5, 6. And we'll have a new decimal point here. Now, our number is 2.1. We can get rid of these because you don't really need those. You can add as many zeros as you want past here. 0, 0, 0, repeating. So now we have 2.1. And if you remember, we moved our decimal point over 6 times. So now we have times, that is the multiplication symbol. And in scientific notation, you usually won't use the circle or the little star thing. You'll use the multiplication symbol because it's usually just A and N, and you always replace those with the numbers, and you don't have any variables in your final expression. So, and then, so use 10 to the power of 6. So, if we were going to put the decimal going to the left, say in this number, .000000000 something, you would use a negative exponent. So to do this problem, you would move this over 1, 2, 3, 4, 5, 6, 7, 8. So that was 8. So now 5.1 times 10 to the negative 8. And there you go. And to solve those problems in scientific notation, you do the problem. 2.1 times 10 to the 23. 7.4 to the power, 7.1 times 10 to the power of negative 77. So, scientific notation, a new video coming out on that. And now let's just do some practice problems for some negative exponents. So, let's do 5 to the negative 2. So here you go, pause the video to do these. Answers again in the description. So just another piece of information that I've written down somewhere. Another good piece of information is when you say, let's do 3, everyone loves 3, to the power of 0, any number, you can put 4 in there, 6, 9.925, that any number, so any number to the power of 0 equals 1, except for 0 itself. So that's all for today. Leave a like, subscribe, and don't forget to check out my main channel, Awesomeness 751. I have answers to all the practice problems in the description, and keep a lookout for my scientific notation video coming out, and tons of other math videos yet to come. Bye-bye.